Turn to the back of the page first. So here are the test topics. Inverse trig derivatives, being able to apply them, just like all we did yesterday in class. Implicit differentiation involving trig, change line equation. You guys saw this on your quiz, involving implicit differentiation. Particle motion problem, just in terms of getting from position to velocity to acceleration. Related rates involving trig. We did that on Monday. We'll practice some more with that. Mean value theorem, trig derivatives, average rate of change. And then you'll get a trig curve sketching problem involving sine or cosine. Okay, and you'll get to use your calculators as well. Okay, yeah, make sure we know unit circle values, make sure we know our derivative rules. So here are the rules that you're responsible for the test. We just did the arc trig derivatives, right? These are the ones that we were practicing yesterday. The 6 trig derivative rules that you guys were applying on the quiz, and then natural log and e to the u. Okay. These are the ones that major ones that we've seen on the quiz as well. So, okay, so those are the derivative rules that I'm going to ask you to know for the test. All right, let's go to worksheet 1. So the goal is that we can get through worksheet 1 or one of the worksheets each of the days. So today we'll do worksheet 1, tomorrow worksheet 2, worksheet 3, worksheet 4 on Monday, and then I'm going to save worksheet 5 for the morning review on Tuesday. Okay. Worksheets 1 through 4 will count towards your homework grade. So I think we'll be able to get through most of everything, if not all, by the end of class. And then beginning of class next day, I'm just going to walk around and check you guys off for homework grade. Okay. So typically, this unit, you're not going to have much homework grade. Just to keep up with classwork, then that's going to be your homework. Okay. All right, so number 1, determine whether Rolle's theorem can be applied on the function secant of x on the interval from negative pi over 4 to pi over 4. If so, find all the values of c on the interval such that f prime of c is equal to 0. All right, so we know that secant potentially has vertical asymptotes. Doesn't mean that because there's a vertical asymptote that we're going to fail. It just means that we have to double check that our asymptotes are not interfering with the interval. If it does interfere, then we stop the problem. Function is not continuous. The theorem doesn't apply. All right, so let's just consider secant of x. So secant of x is same thing as 1 over cosine of x, right? So whatever causes cosine to be 0 is going to force this to be a vertical asymptote. So where is cosine equal to 0? X equals, pi over 2, 3 pi over 2. And then if we get coterminal angles to see if it'll cause any issues with the negative version, we can subtract 2 pi from pi over 2, subtract 2 pi from 3 pi over 2, and we get negative 3 pi over 2, and we get negative pi over 2. And if you look at our interval from negative pi over 4 to pi over 4, none of these are going to interfere. So we're safe. Our asymptotes are none of these are going to fall between the interval from negative pi over 4 to pi over 4. The closest we have is pi over 2 and negative pi over 2, but these are going to be on the outside. Can you pass? Right, so our function is continuous and differentiable, so we can go ahead and list those conditions out. And Rolle's theorem is similar to mean value theorem, same formula. We just have to show that the endpoints produces a slope of 0. Okay. Continuous is with brackets. Differentiable is with parentheses. So Rolle's theorem is the same as mean value theorem. I'm just going to list out, I'm going to call this mean value theorem, but there are 3 things that we want to involve. Okay. The first thing is we want to find order pairs at the endpoints and build the slope. And that slope needs to be what if it's Rolle's theorem? 0. Okay. All right. So we should be able to get that confirmed. Next step, we're going to find the derivative function. And the third step, we'll set them equal to each other and solve for C. All right, so let's find our endpoints here, f of negative pi over 4. All right, secant of negative pi over 4. Negative pi over 4 is the same thing as 11 pi over 4 in the 4th quadrant. Secant is similar to cosine in the sense that cosine is positive in the 4th quadrant. Secant is also positive in the 4th quadrant. Secant is the reciprocal of cosine. Okay, so what's cosine of 11 pi over 4? Yeah, root 2 over 2. So just flip that, and that will be your secant. Secant will be 2 over root 2. The other endpoint, secant of pi over 4. First quadrant, also 2 over root 2. So we do change in y over the change in x. Am I going to get slope 0? I will. Yeah, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's 0 over a non-zero, which we know is a real number. So we're able to confirm Rolle's theorem is going to apply. We have continuous, we have differentiable. The endpoint produces slope 0. So we have this piece figured out. Next up, let's find the derivative. Right, secant's derivative is what's secant's derivative?
Times u prime.
Yeah, so secant u tangent u times u prime. Now it's only an x, so u prime is just going to be times 1, so it's just going to be secant x tangent x. Good so far?
Yeah.
Okay, we're going to set the derivative equal to 0. Now, whenever you're setting the derivative equal to 0, typically what that means is just the numerator equal to 0. Okay, if there's a numerator and denominator within your derivative, it's just the numerator equal to 0. The reason why is because if you set the denominator equal to 0, then you're looking for vertical asymptote or slope undefined. We're looking for slope 0, so it's just going to be the numerator. And the reason that I point that out is because anytime you have trig functions and you're working with them, it's always easier to think in terms of sine and cosine. So we can always turn this into any trig function into sine and cosine. So this ends up being sine over cosine squared equals 0, but we're only dealing with the numerator, so we only have to worry about where is sine equal to 0, right? The cosine squared is not going to matter because we're not looking for slope undefined. We're looking for slope zeros. Okay, are we good with that? Okay, so I'm just looking to see where sine is equal to 0, and I'm guaranteed to find a C value or X value solution in this interval. Okay, we've already gone past all of our conditions. We're guaranteed to find a place where the slope is 0. All right, so where is sine equal to 0? Yeah, 0, pi. I'm going to make negative pi as well, just to make sure that I have everything covered. I'm guaranteed at least 1 in the interval. What's my C value? 0. 0 is safely between negative pi over 4 and pi over 4. I have to find at least one solution. Okay. If I got this far in the theorem, I can't walk away with no solution. Okay, let's do another mean value theorem. Well, this is mean value theorem. The previous is Rolle's theorem, but they're essentially the same. Okay, but let's do another mean value theorem problem. Our function is 2 sine of x plus sine of 2x. Find all the values of c on the interval from 0 to pi. Our conditions are easily met because our sine graph has no asymptotes, so it'll be smooth all the way through, continuous and differentiable. There is a need for trig identity when we get to our derivative. So if there's any trig identity that's needed on the test, I'll give it to you. Okay, so you don't have to worry about memorizing it. So in this case, we're going to need this a little bit later. Okay, so let's go through our steps. All right, so continuity is no issue, differentiable is no issue, but we have to make sure we state it. So let's go ahead and state those conditions. All right, so here's our theorem. F of b minus f of a over b minus a equals f prime of c. So spend your initial steps finding your order pairs. So plug 0 into the original function, get that y value. Plug pi into the original function, get that y value. Find the slope between the two endpoints, and that can take care of this piece that we're looking for. And after that, we're going to find the derivative function. Then after that, we'll set them equal to each other and solve for x. All right, so let's see what we got when we find our order pairs. So f of 0 is just 2 sine of 0 plus sine of 2 times 0. That's just going to be sine of 0, which is 0. F of pi, also 0. So my slope ends up being 0. So 0 minus 0 over pi minus 0. So this, we could have called this, it would have passed Rolle's theorem as well. Right? But we know mean value theorem can take any slope value as long as it's a real number. But Rolle's theorem is very specific. It has to be slope 0 in order for us to move forward. Okay, are we good so far? All right, so we have this piece of the puzzle figured out. Next piece is the derivative, right? Let's find f prime. 2 sine of x becomes what's sine's derivative? Cosine. Yep. Yep. So 2 cosine of x times 1, right? That x won't produce anything except 1. Okay, and then what's sine of 2x's derivative? Yeah, cosine of u times u prime, so cosine of 2x times 2, okay? All right, next step. We have our derivative function, we have our slope. And we're just going to set them equal to each other. Now, the cosine of 2x times 2, we have to do a little bit of work there to get this into something that's a little bit easier to work with. So we have that trig identity that can expand that cosine 2x into something that is more manageable in terms of factoring. So we're going to replace cosine of 2x with 2 cosine of squared x minus 1. Okay, so cosine 2x times 2, the same thing as pulling the 2 out in front as the coefficient. And cosine 2x, we can expand to be 2 cosine squared x minus 1. We can go through a factoring process, make sure that we keep everything together on the same side. If I have my degree 2 descending order, cosine squared followed by cosine x followed by the constant, I can go through factoring steps, factor the 2 out first. And if you don't want to factor in terms of cosine, then you can do an easier version of this problem. 2x squared plus x minus 1. This can factor to be oops. Two x minus 1, x plus 1, and then replace the x back with cosine. So 2 cosine x minus 1 times cosine of x plus 1. We can ignore the 2. The 2 is not going to produce any critical points for us. So we should have to set 2x minus 1 equal to 0, the cosine of x plus 1 equal to 0. And then after we find our critical points, we have to make sure that we can find all the solutions inside the interval from 0 to pi. Okay, so we have cosine of x equals -1 and cosine of x equals to 1/2. Cosine is equal to -1 at 3 pi over 2 and negative pi over 2. Cosine is equal to 1/2. It's in that pi over 3 family. So pi over 3, 5 pi over 3, first and fourth quadrant. But we're only looking for a solution between 0 and pi. And if it lands at the endpoint, that's not good enough. Endpoints are not considered solutions for mean value theorem, Rolle's theorem. So if it lands at an endpoint, we have to remove that as well. It's got to be between the 2 endpoints. So the only endpoint, the only critical point that we have that we can identify is at pi over 3. Okay, any questions with number 2? All right, number 3, we're asked just to find the derivative for f of x. All right, what's needed and what's involved here if we want to find the derivative? What do you see? Okay, so obviously we need e to the u derivative. We also need arc cosine or inverse cosine derivative. Anything else? Something about this x squared arc cosine 5 minus x squared. Product rule, yeah. So recognizing, okay, x squared is not the same as arc cosine. Those are two separate functions. We have to go through a product rule. Okay, so as a reminder, arc cosine is similar to arc sine. It's the u prime over root 1 minus u squared, but just with a negative in front. Okay, so see if you can step through your rules there and then apply product rule as well. And then once you find your derivative, you don't have to clean up. You can leave your answer unsimplified or leave your derivative unsimplified. F prime g plus f g prime, x squared becomes 2x, g stays the same, f stays the same, g prime, arc cosine of u becomes negative u prime. We got to keep track of our negatives here. The negative is from the rule, the negative 2x is from the u prime, all over square root of 1 minus u squared, minus e to the u times u prime. You can leave your answer like this. I just decided I want to clean up that f and g prime into one fraction, but you don't have to.
You have to the e.
Oh, this part
The
here?
derivative, you're right. But you can leave it.
Yeah, I can leave it. That's fine. I just pushed this out in front, but yeah, it doesn't matter. All right, page 2. All right, object's position is given by f of t equals 2 secant cubed t over 6, continuous and differentiable. Find the average velocity. So average velocity is just change in position over change in time. We're just finding slope. But it's easier, I think, if we just have that trig exponent in a better place. Easier for us to work with. So let me start off by rewriting our f of t and just get that exponent in a place that's easier for us to work with. I think there's always a good habit, even if you're not finding the derivative, it's just easier to see what needs to happen. Your order of operations is going to be easier to follow if you get that exponent outside a set of brackets or parentheses. Okay, so let's just find order pairs and then change in position over change in time. So let's find f of 0. Let's find f of 2 pi, and then just find the slope between the two endpoints. All right, try that. Right.
Like it's, I feel like plugging the same thing. Not always be 0.
That is not necessarily because it's over 6. So
Can we get calculator?
yes, but I still want to see the work. Yeah, I still want to see the work. Yeah. So you get to use your calculator to double check everything that you do, but I want to see the work. Still relying on your unit circle knowledge. All right, so secant of 0. Secant of 0 is the reciprocal of cosine of 0. Cosine of 0, you know, is 1. If you flip 1, you still get 1. So 2 times 1 cubed, it's just 2. Make sure that we don't do 2 times 1 and then cube that. We're always, exponent is always taking the first priority over multiplication. So we do 1 cubed first and then multiply by 2, which is 2. F of 2 pi. Secant of 2 pi over 6, the same thing as secant of pi over 3. Secant of pi over 3 is related to cosine of pi over 3. Cosine of pi over 3 is 1/2. Flip that, you get 2 over 1. So 2 cubed is 8. 8 times 2 is 16. And now we just find the slope between the two endpoints, right? Change in position over change in time is equivalent to average velocity. So 16 minus 2 all over 2 pi minus 0. 14 over 2 pi, you can leave it like this. I just reduced it to 7 over pi. And then our units of measure is meters per second because we did change in position over change in time. That's going to create a velocity unit. Okay, at what point in time is the instantaneous velocity equal the average velocity? So anytime you see instantaneous rate of change equal the average rate of change, or in this case, instantaneous velocity equal average velocity, that is indicating to us that they're trying to get us to use mean value theorem. Okay, so here is the notation for average rate of change. Here's the notations for instantaneous rate of change. So we're just trying to set up mean value theorem. It says set up the equation, but do not solve. So we already have the average rate of change. We just need to do the instantaneous rate of change. So we need to find the derivative. Okay, so we need to find f prime. But to find f prime, we got to go through what? Chain rule. Yeah. So figure out your outside, figure out your inside. Take turns building each part's derivative. And then once you have your derivative set equal to 7 over pi, and then you can stop. It's not, this problem will be tough to do by hand. So we're just going to do the setup. So the outside is portion is the 2 bracket cubed. The inside portion is the secant of 1/6 t. We're just taking turns with each derivative, right? So 2 bracket cubed becomes 6 bracket squared. Keep the inside intact. And then ready for the inside, secant of u becomes secant u tangent u times u prime. So set that derivative equal to 7 over pi, and then we can stop. Yeah. Well, if you do 14 over 2 pi, that's fine as well. But yeah, we're just setting our average rate of change, which we found from part A, equal to the derivative from part B.
Is it fine if we don't?
That's fine. Yeah. Yeah, if you don't simplify f prime, that's fine. But I just cleaned it up. I merged it together, but you don't have to. Any questions with building the derivative? Notice that I rewrote t over 6 as 1/6 t. It's not, you don't have to do that, but I find that some students get a little thrown off when they see t over 6 and they're thinking, wait, how do I find the derivative of that? Do I have to go through quotient rule? Remember, anytime you have a number in the denominator, you can always push it out as a fraction, and that way it just feels a lot cleaner. All right, part C, what is the instantaneous velocity of the object at t equals pi seconds? So what can we do here? Plug pi into f prime, right? Your f prime is basically your derivative function. Yep. So plug pi in for t, and then try to get it out of trig notation into a numeric value. But once you get it down to a numeric value, we can stop. You don't have to go any further. Okay, secant of pi over 6, similar to cosine of pi over 6. We know cosine is √3 over 2. Flip that, we get 2 over √3 for secant. Tangent for pi over 6, sine over cosine. And also 1 over √3. And again, if you don't clean up your f prime value, it's fine, but you have to at least get it down to a numeric value before you stop. And again, you don't have to rationalize your denominator either. If you leave radicals in the denominator, College Board will accept that unsimplified version as well. Okay, part D, working with the same derivative, just plug in 2 pi to f prime.
Check out multiplying the square roots with like √3 to the third power of √3.
Yeah, the derivative, right? Okay, so 2 pi in for t, we get secant of 2 pi over 6, the same thing as secant of pi over 3. Secant of pi over 3 is related to cosine of pi over 3. Cosine of pi over 3 is 1/2, so flip that, we get 2. Tangent of pi over 3 is root 3 over 1. Part E, find the equation of tangent line. Well, you have the slope already from part D. You just need to find the order pair. So plug 2 pi back into the original function, get that order pair, and then point slope form. All right, so 2 pi into the original function, secant of pi over 2 pi over 6, same thing as secant of pi over 3. Secant of pi over 3 is reciprocal of cosine of pi over 3, so 2 cubed times 2 is 16. We have our order pair, we have our slope, point slope form. Okay, so we're done with our classwork for tomorrow, but I'd like for us to at least spend 5 minutes just see if we can get ahead into worksheet 2. So turn to page 3. So this is just a solving equation. I want us to involve inverse trig so that we don't have to rely on double angle identity. Anybody still need to look at part B or E? So let's use inverse trig. Inverse trig can allow us to handle anything other than 2x. It can even handle 3x or 4x or 5x. We can just involve inverse trig. So move that cosine over as inverse cosine of 1. So now we're just asking ourselves, okay, when is cosine of theta equal to 1? That's basically what that notation means. So let's see if we can list out some solutions. We may have to go past 2 pi because eventually our solution is going to shrink once we divide by 2. So let's go a little further than we're expecting, and then that way we can make sure that we have everything inside the interval. All right, so when is cosine equal to 1?
0.
Yep, 0. 2 pi. Let's go a little further. Yep, so 4 pi. Yeah, maybe I don't need all the way to 8 pi, but it's going to just list them out just in case. Okay, I want to solve for x. Divide by 2, same thing as multiplying by 1/2. So 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 4 is 2. 3, and 4. Okay, we're looking for solutions between 0 and 2 pi, so we're not going to include 0, 2 pi, 3 pi, or 4 pi, so our only solution is at pi. Okay, let's just do number 2 and then we can stop. Number 2 says find the critical points for the function in the domain. So critical points means set y prime equal to 0. So go ahead and try that. You know the rule for e to the u is e to the u times u prime. Okay, so there's my e to the u times u prime. E to the u is just the original function that's given to us, and then times u prime. X becomes 1, sine of u becomes cosine of u times u prime, so cosine of 2x times 2. Set that both parts equal to 0. And let's look for critical points. So the issue is that if I try to set that e to the x plus sine 2x equal to 0, this is no solution, because if we want to go any further, if you want to bring that x down, maybe you will take the natural log of both sides, but natural log of 0 is undefined, so we can't go any further. Even if we want to take natural log and bring that exponent down, we're stuck with no solution. So nothing can come out of that e to the x plus sine 2x. We can ignore that. So we only have to focus on the 1 plus 2 cosine of 2x equal to 0. So get cosine of 2x by itself, use inverse trig, and work your solution similar to how we did with number 1. Okay, so 1 plus 2 cosine 2x equal to 0. Subtract 1, divide by 2. And isolate that 2x first. And move that inverse cosine over as inverse cosine. So now we can just ask ourselves, okay, when is cosine of theta equal to -1/2? We know it's going to be in that pi over 3 family, but second and third quadrant, so what? Yeah, 2 pi over 3, 4 pi over 3. Yeah, let's keep going a little further. We know we're going to shrink those values, so I'm going to go past 2 pi. So my initial interval is at second and third quadrant is 2 pi over 3 and 4 pi over 3. If I want to keep going a little further, add 2 pi, get coterminal angles. 2 pi over 3 plus 2 pi is the same thing as 2 pi over 3 plus 6 pi over 3. That's 8 pi over 3. 4 pi over 3 plus 2 pi is the same thing as 4 pi over 3 plus 6 pi over 3. That's 10 pi over 3. Okay, so here are our potential solutions. Divide everything by 2, multiply by 1/2. And we get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, these all happen to be clearly inside the interval, so it is good to go all the way up to 10 pi over 3 because we do end up with a solution that is still in our interval. Okay, so tomorrow I'm just going to check pages 1 and 2. No homework tonight. Tomorrow we'll pick up with page 3 and 4. Sorry, I haven't had a chance to get back your quiz. I'll definitely get it back to you tomorrow.
No. No, but that was just.
Oh.
Yeah, I just want to say, I just saw like your line from Trig, so I apologize about that, about going over my log quiz.
Oh, okay.
But if you want, I can, if you're available tomorrow morning, I could come in and go over it, but I feel like I'd be fine recovering it anyways.
Okay, what did you get on there?
56. Yeah.
Okay, so if you feel good about it, then, Friday's recovery, give me your quiz, I'll just circle similar problems and you can redo the 75.
Okay,
Okay,
that's fine.
sounds good.
What's it?
Also, reminder, logs quiz recovery is Friday, so Friday at 7:30. You'll just redo the similar problems that you missed up to 75.
There's some scenes there. You met the Lightful Day. Yeah. Lightful Day.
Wait,
You watch Stranger Things? You watch Stranger Things? What?